In the last video, we worked out the step response of an RC circuit, and now we're going to look at a real example. So this is our answer. This is the step response, the total response to our circuit to a step input. And what does this look like? So I'm going to move down a little bit. We'll make up a circuit and we'll do a real example here. Let's say we do a step, and the step goes from 0.2 volts up to, say, 1.1 volts, and let's let R equal 1 k ohm, and let the capacitor equal 4 microfarads. So now let's plug these values over here into our solution and see what we get. Now, first I'm going to work out RC. RC is equal to 1 k ohm times 4 microfarads. And what does that equal? K is plus 3, and micro is minus 6. So 1 times 4 is 4, and plus 3 minus 6 is times 10 to the minus 3. And that is in seconds, so that's equal to 4 milliseconds. Now let's plug the rest of our values in here. V of t, the total response, or the step response, equals V naught, 0.2, minus Vs, that's the step voltage, 1.1, times e to the minus t over 4 milliseconds, plus Vs, Vs is 1.1. So I went ahead and I plotted this on using a computer, and we'll see how close this comes to what we sketched earlier. So here's Vt, or the step response, the total response of our RC network to a step voltage. The step voltage is here in rose color, and it goes from 0.2 volts up to, oh, I got it wrong, 1.2 volts. Let's change that to the right number. 1.2, 1.2. And this is what it looks like. And if you go back and compare this to what we saw, what we sketched at the beginning, it'll look pretty similar. So the output voltage, the voltage on the capacitor here, starts at V naught, which is 0.2. It ends up at Vs, which is 1.2 in this case, and that's the forced response up here. And in between, it did that smooth exponential curve. That's what the step response of an RC circuit looks like.